In the second part of the video, we have now introduced the kinematic equations, which have 5 variables and not 3. So we've got an equation that relates the final velocity to the initial velocity, acceleration, and time. We've got the distance equals the initial velocity times time, plus 1/2 times at squared. We've got the final velocity in terms of the initial velocity and the acceleration and distance. And we've got the distance in terms of the average velocity, which is just 1/2 of the initial plus the final velocity times time. Now, in this case, if you look closely, you will see that for all of these equations, you have 4 out of these 5 variables. Right? None of these equations have all 5, and none of these equations have 3. Let's just have a look, for example. So for this equation we have Vf, we have Vi, we have A, and we have T, but we do not have D. In this case we have D, Vi, T, and A, and T again, but that's just 2 T's. We do not have any Vf, right? In this case we do not have a T, and in this case we do not have an A. The general procedure for solving these kind of problems with kinematic equations is to figure out what you need to calculate. So for example, if I need to calculate A, but I don't have D, well then I need to find the equation that has A in it but doesn't have D. So I'd use this equation because I don't know what D is, but I need to calculate A. But we can try this out by going through some practice questions. So firstly though, I want to show you the difference between modeling with constant acceleration and constant velocity. So if I were to say, okay, I've got a car with a stationary start traveling in 42 seconds 1.5 kilometers, right? So 1.5 kilometers is 1,500 meters. Now we could also then model that so 1.5 kilometers is 1,500 meters. So what we should always do is list the information that we know. And a convenient way to do this is to list it in the tables. In a table. So in this case, we could list this as Vi is equal to 0, and A is equal to something we do not know. We do not know what A is. Right? But what we can do is we can try to calculate with constant velocity and see what we get, and compare that with what we get if we model it with constant acceleration. Right? So using these equations. So let's start with the constant velocity case. Well, that's just simply the distance divided by the time. 1,500 divided by 42, right? According to this equation, which would be 36 meters per second. Well, now, in this case, what values do we know? Well, we don't know what the acceleration is. So that means we cannot use any equation that has acceleration in it. So we can't use this equation. We can't use this equation, and we can't use this equation. But we want to calculate the final velocity. So we can use this equation. We know the distance, which is 1,500. We know the time, which is 42 seconds. And we know the initial velocity. And this is the tricky thing. It doesn't say, but it says it's stationary. So we know the initial velocity is 0. Right, so we want to calculate Vf. Right, because there's no A's, again we cross out those equations, and so we use this equation. And then we have to rearrange. So here you might want to refer to my previous video. Right, this is why it's so important to know how to rearrange equations using algebra. And once you've rearranged the equation, you should be able to get to this point, right, by bringing the 2 up and bringing the t down. And then remembering that Vi is 0, we quite simply have 2 times D divided by T is equal to Vf. So what we actually find is it's 2 times D over T. Wait, what? No, that's exactly right. So look at this. Think about this carefully, right? If we assume there's a constant velocity, then the whole time the car will be going at 36 meters per second. Now, on the other case, if there's constant acceleration, it starts at 0, and by the end, it'll be going its fastest speed, right? The average of this whole speed will be 0 plus 72 over 2, which is 36. So the average speed in both cases is the same. But if it's a constant acceleration, it will end up with a speed that's twice as fast as the average.